Okay, I wanted to make a video on the 9-1 set, but first I wanted to talk about something that was introduced yesterday in the 9-1 task, and I want us to look right here. We talked about this briefly, and I find that this notation can be really tough for people to understand. So this says tested negative / TB means the number of patients who tested negative given that they have TB. Okay, so I know I talked about it yesterday, but I just want to talk about it one more time, that what comes after that little line right there, is the given number. So for up here in the tree diagram, it's given that they have TB. That's this, okay? So that would be 380. And then tested negative is what comes before the line. So of those who have TB, how many tested negative? Would be 19, okay? So what's after this given line is the denominator, and you can think about it that way. So what comes after that line is TB. Patient has TB. So that's why I made this the denominator, and then the numerator was what comes before it. And that's going to be really important with what we do in the chapter and what we review here at the start of class today. So as I do the 9-1 set, you can just fill it out on your Go Formative. So it says, given the tree diagram below, answer the questions and to determine the probabilities. The diagram represents the number of plate appearances during the first month of a minor league baseball season. Okay, so what we have here is the very first thing is on the tree diagram is whether the person hitting is a right-handed batter or a left-handed batter. And then after that, this would be a right-handed batter facing a right-handed pitcher. This is a right-handed batter facing a left-handed pitcher, and then a left-handed batter facing a right-handed pitcher, and a left-handed batter facing a left-handed pitcher, so right-handed and left-handed. Okay, so that's kind of how this reads, and then we have to answer a bunch of questions off of this, okay? So for number 10, how many times did a batter come to the plate during the time period? Okay, so for that one, we had 1193 come to plate as right-handers, and 417 come to the plate as left-handers. So we would just have to add those two together, and that is 610 batters. Okay, number 11, based on this data, if you're a left-handed batter, what is the probability that you will face a right-handed pitcher? So the way that this is going to be presented more on tests is in probability notation. So this would be, just give me a moment to write it out for you. If you're a left-handed batter, what's the probability you'll face a right-handed pitcher? So this is probability of facing a right-handed pitcher given that you are a left-handed batter. So this is just what we did before, okay? All right, so I know that my denominator for my probability fraction is going to come after this line. You could even think of this as like a fraction bar kind of for now, okay? So my denominator is going to be left-handed batters. Well, how many left-handed batters are there? There's 417. And then the numerator is going to be the part that comes before, facing a right-handed pitcher. So we have our left-handed batter and then our right-handed pitcher. That's 255 out of 417. So out of all the lefties, 255 of them faced a right-handed pitcher. Based on the data, if you're a right-handed batter, what is the probability that you'll face a left-handed pitcher? So this is kind of the same thing as reverse. I'm not going to write the whole thing out, but basically you have your line here, and you're given that, you're righty, you're right-handed batter, and then you're facing a lefty. Okay, so the total on this one is the right-handed batters, which is 1193. And then of those right-handed batters, how many of them faced, so right-handed batters faced a left-handed pitcher? It would be 693. Okay. Going on to 13. What's the probability a left-handed pitcher will be throwing for any given plate appearance? Okay, so I look in the chart for my left-handed pitchers. So that is this and this. So it would be 693 of them through to right-handed batters and 162 of them through to left-handed batters. So what I would do is I would just add those two numbers together for number 13, and 693 plus 162 is 855. 855 out of the total. So how many total plate appearances were there? Well, that's our question for number 10. Okay, or our answer for number 10, which is 1610. Okay, what's the probability that a left-handed batter would be at a plate for any given plate appearance? Okay, so this time, if this one was left-handed pitcher, this one is left-handed batter. Well, there's 417 left-handed batters. So if you look over here, I see that there's 417 left-handed batters. And that is going to be out of all the plate appearances, which is 1610. Okay, so hopefully that was helpful in understanding the tree diagrams a little bit and the notation. Just remember, with the given part, just think about what is the numerator and what is the denominator.